Hello everyone, my name is Shambhavi and welcome back to my channel Fun with Data Science. So basically in the last video we have discussed about the random variable. So let me take you to that slide and yeah, this is the one which we have discussed. We have discussed that what are random variables. After that we have seen two types of random variables that were discrete and continuous. And at the last of the video I just told you how to make a single graph, and then what we did was we had taken x and we had done that number of facing up on a fair die. So this was basically I have told you about the probability distribution, right? Like how to make the graphs. And then whatever I in this discrete random variable I also proved that where I have written the probability of each value of a discrete random variable is between 0 and 1, and the sum of all the probabilities is equal to 1. So basically what example we have taken is that I had rolled a die and dice, and simply what were the outcomes? The outcomes can be either 1, 2, 3, 4, 5 or 6. So basically what I did that I only simply I did the summation of all these things and simply I got the output as 1. So simply I wanted to prove that the sum of all the probabilities is equal to 1. So right, I proved this line. Now today we are going to see that properly, that what are these probability density functions, like that is for the probability distribution also, and we are going to see it for the continuous random variables. In the last video we have seen for the discrete one, so we are today going to follow the continuous continuous random variables. Okay, so just let me define it first. What about the probability density function? The graph of a continuous probability function is a curve. Okay, so now this is the thing that whenever we are going to draw the graph for the probability function, for the continuous probability function, it is always a curve. Okay, now after that the probability is represented by the area under the curve. So we have drawn a graph. Now I will give you the example. First let's understand the definitions only. Whenever we are going to draw a graph for this continuous probability function, we are going to get a curve, and the area for that, the probability is represented by the area under the curve. So whatever the area is under the curve, or whatever the area you are taking, a specific area under the curve, whatever you are taking is represented as the probability, right? We will see this using an example. Just first understand the definitions. So the curve is also called the probability density function. So the curve which we are going to make in the continuous probability functions, which we get as a curve, is known as the probability density function. So I hope you have got an idea about the probability distribution density function, that what is it actually. So let me revise the definition once more, that the graph of a continuous probability function is a curve. Probability is represented by the area under the curve. The curve is called a probability density function. Now one more thing here is that we use density function. We just denote this probability density function using fx. Okay, so it's the, you can say it's a notation for writing this. So we use density function fx to draw the graph of probability distribution. We'll see all these things in some minutes only. Okay, so now let me tell you a little bit about the distributions first. We have seen about the probability distribution, but there are also some more types. So let me introduce you to them only first. So for that what I'm going to draw is I'm simply going to draw a simple graph. Okay, now let me take a different color, and okay, let's choose from here, and okay, I will have this one. Okay, so let's say I'm gonna make a graph like this. So if we somewhat see a graph like this, what is this graph called as? So a graph which has this horizontal and vertical lines, this graph is known as a uniform distribution. Uniform distribution means continuous distribution, and we are saying that the distributions are not varying. It is simply like starting from here, going to a point and then ending, right? So it is known as a uniform distribution. Now just let me hold on and let me okay, it's too much thick pen, and let's okay, fine. Now I'm gonna name these things. Let's say I write it 1, 2, 3, 4, 5 and 6. Okay, so now let's say I want to find the area between this 3 and 4. So what I'm gonna do is that firstly I'm going to color this portion, so that we get a idea that we are going, if I want to find the area of this, right, of this function. So what I'm going to write here is that firstly let me write that it is a uniform distribution, right? Whenever you see a distribution like this, you can name it as uniform distribution. Okay. Okay, so distribution. So I have written this. After that, when I want to find the probability, so what we discussed in the above definition, that it is the area under the curve. So here basically it is not a curve. So for that curve we are going to see another example, but I wanted to let you know about a different distribution. So this one is the uniform, and now when I'm gonna write, like I want to find the probability. So how would I say that? So let's say x is the probability, right? And now I would simply write that 3, like x is greater than 3 and x is less than 4. So like x is our probability, let's say, and it will lie between, like it would be either greater than 3 or it would be less than 4. So if we want to write it in terms of the probability, so what we are going to do is that we are simply going to write p, and in brackets we are going to write that x is greater than 3 or x is less than 4. So this is the terminology, and like this is the way how we are going to write this in the terms of probability. Okay, so firstly I told you about the uniform distributions. Now let me move towards the next. Okay, and okay, for next, like let me take that. Okay, and now let's go a little down. Okay, so hold on, I'm so sorry. Like simply let's take this one, right? And now I'm going to just make it one more graph, and let me move a little down. So like we have seen about the uniform distribution. Now my second example for you all is like we are going to see another one. So the next one which we are going to see is the distribution, exponential distribution. Okay, so for that, as you all have seen the graphs for the exponential like this. Okay, I'm so sorry. So it is something, like this. Okay, and it goes to like infinite. Okay, like wherever it is. So basically this is a type of a exponential graph, right? And you all have must seen these graphs in the mathematics term. So in here also we call it as exponential distribution. If you see a graph including like lines and yeah this curve, so it is called exponential graph, exponential distribution, I'm sorry, exponential distribution. Okay, so just let me write it down, and yeah. Okay, now if let's say I want to find the probability between 2 and 4, and yeah, if I want to find this probability between 2 and 4, so like we have written earlier, like how we have written was, we have simply written p, and after that we have defined the starting and the ending points, and in the between we have written x. So we are going to do the same thing here also. So what I'm going to do is that I'm going to write p. Okay, just let me take the pen. Okay, so simply what I'm going to do is that I'm going to write P, and after that I'm going to define the ending and like starting and the ending points in between. I'm going to write X. So it is like something that our X should be greater than 2 and it should be less than 4. So X, what is the X? X is the area. X is the probability of that right area. So in the above what I defined is that like the probability is represented by the area under the curves, right? So here we are taking this like this portion, and it is defining that x should be between our 2 and 4, so it should be greater than 2 and it should be less than 4. So this is called the exponential distribution. Okay, now moving toward the third distribution, I have one more distribution, and which is, just hold on, let me, okay. Okay, sorry. So now moving towards the third distribution, and our third distribution is known as a normal distribution. Now just let me, okay, so like I can't draw this distribution like this. So for that I would be needing the x and y whole, like that line only. Yeah, this one. Okay. So this is something in which I'm going to draw a normal distribution. So let me keep it this side, and okay. So just let me take one different color. Okay, so this one, and let me take a little bit more. So if we are gonna see any graph like this, okay, so it's not seeming like that, and okay, so this is a graph, like this is the normal distribution, normal probability distribution. Now let me tell you like what are the things that we are going to do. So let me name it. It is normal distribution. So here I introduced you to three types of distribution. First was uniform, second was exponential, third is normal. Now let's say I'm going to define some points here, 1, 2, 3, 4. Okay, let's say -1, -2, -3 and -4. Okay, and the same time is 1, 2, 3 and 4. Now let's say I want to find the area between this like this 1 and this 3. Like so how we are going to write this is also the same as we were following the previous one things. So for that I will simply write p, and in brackets I'm going to write 1, and yes, x is greater than 1 and my x should be less than 3. So this is the thing that we are going to do. Like simply these were the three type of distribution. So first one was a normal uniform distribution. Okay, so I told you about the uniform. After that was the exponential distribution, and the third one was the normal distribution. Now let's move towards the next thing. Now as I was telling you in the last video that we have taken an example for the continuous random variables, and that was the you can say example in which we have taken the exact amount of rain that will be tomorrow. Okay, so we have taken the thing in the inches, and like we were discussing we were having a discussion about that only. So let's continue with that only, and just let me write here continuous. Okay, so we are going to discuss about the continuous. So here in the last time we have taken an x. Okay, and our x was like it was exact amount of rain tomorrow, right? So it was something like exact amount of rain which like it would be raining tomorrow. And what would be the exact amount of rain? It would be 1 inches, 1.1, 1.2 or 2 inches, something like that, right? So we have taken this. Now let's see, I want to draw a graph for this. Okay, so for drawing a graph, as I told you that for continuous we have a curve graph. Okay, so we have a curve area under the curve. So for that what I need to do is that I'm going to draw a graph. Let's say let it we can see it visually also, right? And now after that what I'm going to do is that I'm simply going to make a curve here. Okay, so which I will be defining as the area under my curve. Now just see the above definition which was written, that the graph of a continuous probability function is a curve. Okay, so here the graph which I had drawn for the continuous probability distribution is a curve, right? And then what was written, that probability is represented by the area under the curve. Now let's say we have, okay, just let me define the things here only. Let's say this value, this peak value is let's say it's 0.5. Okay, and now here I'm going to define the points. Let's say this is 1, and okay, just take this one a little bit this side. Okay, this one is 0, 1, let's say this is 2, then this is 3, then 4, and like it will go so on, right? It will go till infinite. Like this value, this graph which is going, it will go till infinite, right? So let's say I have taken this graph, and in this I have defined the peak value as 0.5, and the these are the inches of rain. So like in the x-axis we have the amount of rain it will happen tomorrow, right? So now when I am going to calculate that what is the probability that it will rain 2 inches tomorrow. Now just understand the things very clearly here, and just let me change the color so that it looks a little different. Okay. Now, if I want to find that what will be the probability that yes, it will rain exactly 2 inches tomorrow. It will rain 2 inches tomorrow, right? So, like some of you will say, okay, this will be 0.5 because the 0.5 is present here. So, like if I write 0.5, no, it's wrong. 0.5 will not be the exact probability that it will rain tomorrow 2 inches. Like I don't want the probability for like it cannot be 1.9, or either it cannot be 1.9 or it cannot be 2.1. Like we are saying that the probability for y is like it will rain tomorrow 2 inches, it will rain, that the probability is 0.5. But no, it's not the case. Like I only and only want the probability that what will be the rain, like it will rain, probability that it will rain 2 inches. we can't take here 1.9, 2.1, or I don't want 1.999. I don't even want a single decimal place to be go here and there. I simply want 2. Like I cannot take 2.00000 something like 1. Like I cannot write 2.00000 and 1. Okay, no, these are not the cases. What I want is exactly 2. It can't be 1.999 or it can't be 2.0001. Okay, so this is the thing that I want here. So for that, what I am going to do is that now let's say we were writing the above terms in the like above graph. We have seen that we were writing them in the form of probability, like 1 is less than x, x less than x lies between 1 and 3, it is greater than 1 and less than 3. We were writing the things here, the x like this. Okay, in the all the three examples, let's write the same for this example also. And if I want to write it in the form of this probability, so what I'm going to write there, like there are two options to write. Okay, so just let me erase this ones. And okay, so okay, this one. So like if I want to write it in the form of that probability only, so what I'm going to do is there is that I'm simply going to write p, right? And then in bracket there are two ways in which we can write. The first one is probability of this my x. Sorry, here it's not y, it's x. Like we have defined x, right? So simply it's x only. So here probability of, like I put this mod so that it do not goes to negative, and in that what I'm going to write is x minus 2, right? X minus 2 is less than zero point 0.1. Okay, so like whatever my x value is here, it should be less than zero point 0.1 when I do it minus 2. Or if you are not able to understand this thing, just leave it, just don't pay attention towards it if you are not able to understand it. Now the next thing that comes here is the another way for writing it. And now let's say I can write that probability for this x. Now what is this x? Now just hold on, let me define that. I want to find this you can say this much area under my curve. So this is my x. Now as I told above that it is denoted by f of x. So my this orange color area, whatever I have made here, something which is my x. X is the probability that I wanted to find, right? So just let me take the color and just let me highlight that. Okay, and yeah, write this one. And how I'm gonna do the things is like simply like this. So here I want to find this probability, right? So for that what I'm going to do is that firstly I'm going to shade that part, that whatever part I want to hide, I want to find the area of, and I have denoted it using f of x. You know, this f of x, this is the denotation, like how we denote it in the form, right? Now let's say for here, now probability for x, what can I write here is that, right? For this one, this x, capital X, so what I'm going to do is there that 1.9, my x, that is the probability, that is the exact amount of rain that will happen tomorrow, it should be greater than 1.9. This one is the capital X, don't mess up with this small x and capital X, right? So till now whatever I have written are all of them are the capital X only, and capital X is like it's the denotation for the random variable, and my capital X belongs to the exact amount of rain tomorrow, right? Okay, so like let me take it down. Yeah, so like my capital X, that is the exact amount of rain that will be tomorrow, must be greater than 1.9 and it should be less than 2.1. Right, so this was the thing which we were discussing here only, that it should be greater than 1.9 and less than 2.1, right? Because we wanted the x is equal to 2, like simply we wanted the probability that it will rain exactly 2 inches tomorrow, right? So this is the thing that I mentioned here, that the probability of x should be like it should be less than 1.9 and it should be, I'm so sorry, it should be greater than 1.9 and it should be less than 2.1. So this is the thing, right? So I have just simply denoted it as f of x here. Now the ones who have like studied about the integrals, they must be knowing that there is a one more form to do the things, right? So now here if I'm going to like if I want to write, so in the form of integral, what I will simply write is that I will simply write integration, okay, integration of 1.9. In the downside, I will simply write 1.9, and the above I will define it 2.1. So now just let me, in the graph also, let me define 1.9 and okay, let me write blue. So this thing is 1.9. Okay, so it will lie between 1 and 2, and this thing is 2.1 because 2.1 will lie between 2 and 3. Let's say I define both the things. Okay, so now if my integral should be between 1.9 and 2.1, and here what I'm going to write is f of x. Now just once more go above for the definitions where I have written that we use density function fx to draw the graph of probability distribution. So we denote it simply using fx. So simply what I wrote here is that integration of 1.9 to 2.1, like I have given the range, that range should be 1.9 and 2.1, and simply I wrote fx then here dx. So this is the way for writing the probability distribution. So probability distribution for my graph which I have presently made for the example which we are dealing, that it is the how much exact amount of rain is going to happen tomorrow, and we have taken a probability that it will rain exactly 2 inches. So these are the things that we do for finding that probability. Okay, now one more thing, if I want to take the whole probability from 0 till infinite, so what is the case, like 0 and from infinite till here, the probability will always lie, the probability for this will always be 1. Okay, so this is one more thing which I wanted to tell. And yeah, and this is the thing that the area under the probability distribution function has to be 1. It is the rule that the area that is under the probability distribution function. So my probability distribution function is like this curve, right, which I have made here. So the area under this should be always be 1. Okay, so now in the next video we are going to see this example for this continuous probability function. So let's once again revise the definitions what we have read, that the graph of a continuous probability function is a curve. Probability is represented by the area under the curve. The curve is also called a probability density function. And now secondly what we have read is that we use density function fx to draw the graph of probability distribution. And yes, I have told about the 3 different distribution, that was uniform, exponential, normal, and simply I told how to write that if you want to find the area, and I'm sorry, if you want to find the probability, to how to simply write that things. And after that I had used this continuous random variable, and yeah, I have introduced to an example here using the graph and all the things. So I hope you got the things and you are able to differentiate between these two things. Now if you have listened the lectures very clearly, so you must be able to revise all the things and remember all the things. Okay, so if you have any doubts, so you can just ask me in the comment box, or you can even rewatch the videos. If you are going to watch this video 2, 3, 4 times, then you are not going to face any of the errors, any of the issues afterwards. Okay, so this is all for this video. Till then, thank you and bye bye.